It starts with a puzzle, a big one. It's about why we're here and why we are the way we are. The puzzle is menopause. Why does it exist? From a purely evolutionary standpoint, it makes no sense. Think about it like this. The main goal of any species, from a genetic perspective, is to make more of itself, to pass on genes. You do that by having offspring, and for most of the animal kingdom, that's the whole game. An animal, a female chimpanzee for instance, keeps reproducing for as long as she can. Her fertility might decline with age, but she doesn't just stop. She doesn't have decades of life left over after her last baby. Her reproductive life and her actual life are pretty much the same length. When she can no longer have babies, she dies soon after. That's the brutal logic of nature. If you're not contributing to the next generation, you're just using up resources. But humans are different, very different. A woman's ability to have children usually ends somewhere in her 40s or early 50s. Yet she can easily live another 30, 40, or even 50 years. That's a huge chunk of her life. A whole second adulthood lived after her own fertility is gone. For a long time, scientists saw this as just a weird byproduct of us living longer in general. Maybe our bodies were just designed to last about 50 years, and modern medicine and better food stretched that out. It was seen as an accident, not an adaptation. It was a bug, not a feature. But what if it's not a bug? What if that long post-reproductive life is one of the most important adaptations in human history? What if it's the key to understanding how a small, weak African ape ended up dominating the planet? What if the secret to our success is grandmothers? This idea is called the grandmother hypothesis, and it turns that old evolutionary logic on its head. It suggests that women evolved to live long past menopause precisely because they were so valuable to their families. They weren't just using up resources, they were providing them, they were ensuring the survival of their own genes, not by having more children themselves, but by helping their children have more children. To understand how this works, we have to go back in time. Imagine a small group of early humans on the African savanna. Life is hard. Food is scarce. Predators are everywhere. A mother has a baby. For the first couple of years, she nurses it. The baby is completely dependent on her. But then she weans it. Now she has a toddler, a 3-year-old. This child is still completely helpless. It can't find its own food. It can't defend itself. It needs constant care and a lot of calories. Now, the mother faces a choice. She can dedicate all her energy to feeding and protecting this one toddler. That means waiting a long time, maybe 5 or 6 years, before having another baby. This is what chimpanzees do. They have long intervals between births, because a chimp mother has to do it all herself. Or something else could happen. What if there's an older woman in the group? The toddler's grandmother. She can no longer have children of her own. She's not nursing an infant. Her body isn't going through the immense strain of pregnancy, but she is strong. And she is wise. She knows where to find food. She knows which roots are safe to eat, which berries are ripe. She knows how to dig for tubers, a reliable source of calories when hunting fails. So, while the mother is busy with a new baby, or maybe out trying to find high-risk, high-reward foods like meat, the grandmother is taking care of the toddler. She's not just watching the kid, she is actively feeding it. She spends her day digging, gathering, and processing food. She brings this food back and gives it to her weaned grandchild. This changes everything. Suddenly, the toddler is not solely dependent on its mother for food. The mother is freed up. The burden on her is lifted. And because her toddler is getting fed, she can have another baby much sooner. Instead of waiting 5 or 6 years, maybe she can have a new baby every 2 or 3 years. This is where the evolutionary math gets really powerful. A female who has her mother around to help will have more children over her lifetime. Her neighbor, who doesn't have a helpful mother, will have fewer. The children with a living grandmother are also more likely to survive. They are better fed and better protected. They have 2 generations of care focused on them. Over thousands of generations, this creates a strong selective pressure. The genes that contribute to living a little longer after menopause get passed on more often. Why? Because the women who carry those genes are the ones who become grandmothers. Yes, they help their daughters have more surviving children, and those children carry the same long life genes. A feedback loop begins. Women who live to be 50 have an advantage. Then 55. Then 60. The trait for a long post-reproductive lifespan becomes embedded in our DNA. It's not an accident. It's a profound advantage. This idea didn't just come from thin air. It came from watching people. An anthropologist named Kristen Hawkes spent years living with and studying the Hadza, a group of hunter-gatherers in Tanzania. Her team was originally there to study foraging patterns. They wanted to see who was bringing in the most food. They expected the big, strong, male hunters to be the stars of the show, and the men were important. When they successfully hunted a large animal, it was a huge feast for the group. But hunting is risky, it's unreliable. Many days the hunters come back with nothing. The team noticed something else. The older women, the grandmothers, were working incredibly hard. They were out every single day, often for hours, digging for tubers. These aren't like store-bought potatoes. They are deep in hard, dry ground. It's tough physical labor, and the grandmothers were masters at it. They were bringing in a steady, reliable supply of calories day in and day out. When the hunters failed, the tubers from the grandmothers were what kept people from going hungry. And who were they feeding? They weren't just eating the food themselves, they were sharing it, specifically with the small children, their grandchildren. They were subsidizing the next generation. Hawks and her team saw the hypothesis in action. They saw Hadza mothers with helpful mothers of their own having children closer together. They saw that the nutritional status of a child was directly linked to how much its grandmother foraged. This wasn't a theoretical model, it was happening right in front of them. But the impact of grandmothers goes far beyond just providing extra food. Their existence reshaped our entire species. It changed our bodies, our brains, and the very nature of our societies. Think about human babies. They are born ridiculously helpless. A baby horse can stand within an hour. A human baby can't even lift its own head. This is because our brains are enormous. To get a baby with a brain that big through a mother's pelvis, it has to be born prematurely in an evolutionary sense. A huge amount of brain growth happens outside the womb. This creates a very long, very dependent childhood. This long childhood is incredibly expensive. It requires a massive investment of time, energy, and food for well over a decade. How could a species afford such a long, vulnerable youth? How could a mother possibly manage it alone? Or she couldn't. The grandmother hypothesis provides the answer. Grandmothers helped make this long childhood possible. Their steady supply of food and care created a safety net. This safety net allowed human evolution to select for even bigger brains and longer periods of development. So, in a very real way, we might owe our intelligence to our grandmothers. Their work created the stable environment needed for our big, complex brains to evolve. Without them, the cost of raising such a slow, maturing, energy-hungry child might have been too high. We might have stayed on a more ape-like path with smaller brains and shorter childhoods. The changes weren't just biological, they were social. The presence of a third generation, the grandparents, fundamentally changed the structure of the human family. It created a different kind of social dynamic. With grandmothers around, you have a new focus for social life. It's not just about a mother and her infant, it's about a mother, an infant, a toddler, and a grandmother. This creates a powerful network of cooperation centered on raising children. It fostered what scientists call prosocial behaviors, helping, sharing, and caring for others' well-being. A grandmother's defining trait is that she helps. She shares food without expecting an immediate return. She provides care out of a deep genetic interest in her grandchildren. This behavior, this instinct to help and share, became a cornerstone of human society. We are one of the most cooperative species on the planet. We are capable of working together in huge groups to achieve incredible things. Where did that start? It may have started in the simple, powerful act of a grandmother feeding her grandchild. She was the model for cooperation. She taught us that sharing resources benefits everyone in the long run. This intergenerational link also became a conduit for knowledge. Grandmothers are reservoirs of information. They've lived longer, they've seen more droughts, more floods, more sicknesses. They know the land, they know which plants are medicinal, they know how to handle social disputes. They hold the group's memory, and they have the time and the motivation to teach. Who do they teach? The children. While the parents are busy with the hard work of daily survival, the grandparents are the ones telling stories, teaching skills, and passing down cultural knowledge. This created a new dimension for evolution. Survival wasn't just about the strongest and fastest anymore. It was also about the smartest and the most knowledgeable. A group with wise elders who could pass on crucial information had a massive advantage over a group that didn't. This intense need to share complex information, how to find water, how to make a tool, who is related to whom would have also created a strong pressure for better communication. It's one thing to point at a lion and grunt a warning. It's another thing to explain a complex family history or describe how to find a specific root that only grows near a certain kind of rock after the rains. The need for grandmothers to teach and for grandchildren to learn may have been one of the driving forces behind the evolution of human language. So we have a chain reaction. Grandmothers help feed their grandchildren. This allows their daughters to have more babies faster. This drives the evolution of longer lifespans. This longer lifespan and extra help create a safe space for children to have a long, slow childhood. This long childhood allows for the evolution of huge, powerful brains. The whole setup fosters cooperation, knowledge transfer, and maybe even language. This is how a small group of apes starts to conquer the world. It's not just one thing. It's a package of traits. And grandmothers are the link that holds the whole package together. They are the catalyst. Their contribution gave early humans a unique demographic advantage. We could reproduce faster than other great apes, but without sacrificing the quality and brain power of our offspring. Our populations could grow more quickly, our children were more likely to survive to adulthood. We could build larger, more cooperative social groups held together by the glue of kinship and shared knowledge. When humans started to move out of Africa, they weren't just armed with stone tools. They were armed with this powerful social structure. They carried with them a system built around intergenerational cooperation. When they faced a new environment, a cold ice age steppe, or a dense tropical jungle, they had a built-in advantage. They had elders who held the memory of the group and could devise new strategies. They had a cooperative childcare system that allowed them to keep their birth rates up even in harsh conditions. They could outpopulate and outlearn their competitors, including other hominin species like the Neanderthals. It's an interesting thought. Maybe the Neanderthals didn't have as many effective grandmothers. Maybe their social structure was different. Maybe that small demographic edge provided by helpful older women was enough to make the difference over thousands of years. It's a numbers game, and grandmothers helped us win. Of course, the grandmother hypothesis is still a hypothesis. It's a powerful and elegant explanation, but evolution is a messy process. There were likely many factors that contributed to human success. Older men, or grandfathers, also played a role. Their knowledge of hunting grounds or tool-making techniques would have been invaluable. Some scientists have proposed a patriarch hypothesis, arguing that long lifespans in men were selected for because successful older men could continue to attract mates and have children late in life. These ideas are not mutually exclusive. It's likely that both older men and older women contributed to the success of the group. But the grandmother hypothesis does something unique. It solves the biological puzzle of menopause. It provides a clear, direct mechanism for how a non-reproductive individual can massively increase her own genetic legacy. The math works, the observations from modern hunter-gatherer groups support it. It connects a biological mystery to a behavioral reality that has profound consequences for our entire evolutionary story. It also feels right on a human level. The bond between a grandmother and a grandchild is a special one, recognized across almost every culture on Earth. It's a relationship often characterized by generosity, patience, and unconditional support. The hypothesis suggests that this bond isn't just a nice cultural sentiment. It's a deep, ancient evolutionary force that shaped who we are. When we look at human society today, the echoes of this are everywhere. In many cultures, grandmothers are still central to childcare. They are the pillars of the family. The saying, "it takes a village to raise a child," is literally true, and for most of our history, grandmothers were the mayors of that village. The modern world has changed things. Families are more spread out, people move for jobs. The direct daily connection between generations can be harder to maintain. But the instinct is still there, the urge to help, to provide, to care for a grandchild is a powerful one. It's a whisper from our deep past. So, the next time you think about human evolution, don't just picture a man with a spear. That's only part of the story. Picture an old woman with a digging stick. Picture her spending hours under a hot sun, working to find food not for herself, but for a small child. See that act not as a chore, but as one of the most consequential actions in the history of life on Earth. That simple act of feeding a grandchild changed our birth rates. It changed our family structure. It helped build our cooperative societies. It gave us the time and the safety to grow our incredible brains. It laid the foundation for culture, for language, for everything we've become. Our greatest strengths as a species A, our intelligence, our cooperation, our ability to learn and adapt, may all be traced back to a grandmother's love. It wasn't our fangs or our claws that let us conquer the world. It was our ability to care for each other across the generations. It was the grandmother effect.